Heapify. The way this works is that you have a heap, right, like this one, and usually you call build a heap map with a heap, the Max heap, when you have a heap and you just inserted the element, and now you want to make sure that it's Max Heapify. What Max Heapify does is that it ensures that each parent node is larger than its children nodes, right? So how it does that? First, we can see here an example, actually here, I think, yeah, here an example in which you pass an array which represents the heap, and then you build a heap, and you can see this will be the output. Now, so how does this work? Given the index, let's say 0, 1, 2, etc., till 6, this is how it will be represented on the heap, and the way it works is that to hit the left, you multiply by 2, and you add an I, 1. And to hit the right, you multiply by 2, and you add 2. And you can see here exactly the methods for hitting left and right. Now, to hit the Max Heapify, you can see that in order to build it, right, what you do is that you go first over each of its parent nodes, right? And the way you find that is by going, you divide by 2, minus 1, and then you count down minus 1, minus 2, right? So for example, in this case, you can see that this has a precise of 6, right? If you divide by 2 minus 1, that should be 3 minus 1, which is exactly 2. You can see that it starts the parent node as 2, right? And you can see here how it checks, right? So it checks that's interesting. You shouldn't check number 3, at least according to this, right? I think this is because the length is actually 7, right? So you will have something 7 hash 2 will be 3 minus 1. Right, this should be still the same. Right, I think it's because you start with an element. Let me see, 1, 0, 1, 2, 3, 4, 5, 6, 7. 0, 1, 2, 3, 4, 5, 6, 7. Never mind. Regardless, that's interesting. You should start by this element. I'm not sure why I printed that. But it should be 2, 1, 0, the elements that it checks, right? Because those are the parents, right? Now, once you go over 2, 1, 0, which is divided 2 minus 1, right? Once you start with this one, what you do on each of them is that you run the Max Heapify, right? And what Max Heapify does is that it basically checks left and right, and then, so let's go over this case. It checks left and right, and it asks the question: if the element on the left is larger than the element on the root element, so this is the root element, and this is the root, and this is the left, and you can see it here, right? And you compare with the largest, and what you want to do is find out which is the largest element, and you move it depending on that, right? So for example here, if it finds out that the left node is larger than this one, then what it is going to do is going to track the largest as the left one, and then it's going to do the same for if it detects that the right is larger than the largest, be it this one or this one, is going to replace the largest by the largest node. And then what you do here in the end is that you check if the largest is not equal to I. What this means is that if the largest index is not the root, it's not this one, then it's going to replace, swap the element root largest with the index. So example, right? It's going to swap this one and this one as the values, and this is how it finds the maximum. And then it's going to run the Max Heapify again, but starting from the largest one. And the largest one can be, remember the largest one, it didn't switch, right? So if this is the largest one, it's going to run Max Heapify starting from here. And let's draw here. So let's draw some examples. If this is, what happened to my pen? If this is 2, 1, 0, right? This is the largest one, so it's going to take this is largest, and because largest is equals to top, it's going to skip everything, and the program is going to end for that root, right? And then if it's not the case, right? If we have 1, 2, 0, this is going to be the largest, and it's going to check this, and it's going to say this is the largest actually, and it's going to swap with the parent node. So you're gonna have 2, 1, 0, and then it's going to run Max Heapify on this index, correct? Yes, it's going to run Max Heapify in this index. Why could that be the case? Because you could have something like 5, 10, 12, 13, right? So let's run this example. So what it's going to do first is going to check here. It doesn't have anything. It's going to check here. It says, oh, there's something here, and we had to bubble it, and let's say this is like 15. This is kind of important, right? So no, that doesn't work. Okay, this is going to be the largest one, so it's going to swap 13, 10, 12, 5, 0. It's going to run Max Heapify in this one. It's going to see that it's okay. So this is okay, this is okay, and then it's going to run Max Heapify in this one, in element 0. And you can see that this one is the largest one, so it's going to replace them by 0, 12, 10, and then it's going to run Max Heapify again in this one, because this was the largest one in the previous here, right? After swapping, this calculates this is the index, and it's going to run Max Heapify here, and we can see that this should be the largest element, so it swaps. We have more space. 13, 12, 5, 10, 0. And you can see this is why it has to run Max Heapify in the largest element that it index that it found, the element, right?